Please welcome Anton.
Thank you. As you probably know, when you have, there isn't a tool or framework that can solve the absence of a proper test process. However, when you have the process in place, you can, through the proper tool and framework, can improve the process further. However, there are different types of frameworks, and this will be our lecture about. So, I'm from Bulgaria. My name is Anton. I have a startup in the field of test automation, and for a couple of years I was working as architect in two big companies in Bulgaria and as a consultant. So here is our game plan. First, I will tell you the difference between library and a framework. Then we will talk about the different types of frameworks, or better say generations. And the second primary part of the talk will be about the fifth generation of frameworks, and we will try to define the must-have features of them, and I will give my best to give you like sample implementations of these features and to show you how you can build it yourself. So there will be like 20 minutes of demos. Let's begin. So a software library usually consists of predefined code, like classes, methods, test data, that you can later use in your tests or code, so that you do not need to write it again. For example, come on. Here it is, the datetime library in .NET Framework. Actually, the framework is something more abstract and generic, and usually you can change it and extend its behavior, usually by overriding the methods. However, there are four things that make the frameworks different than the library. The first one is inversion of control, or in a framework, the overall programming flow is controlled by the framework, not the user. Then the framework gives you usually a default behavior, a meaningful one, like when you call datetime.now, you get the current time. Then you can extend it, usually by overriding some methods or using events. And lastly, you can extend the framework, but usually you're not allowed to modify the code. Here you can see my definition on the slide about what a test automation framework is. But I prefer to give you an example. Imagine that in your company you need to build test automation framework about web. And as you know, usually in web, most companies use WebDriver. In WebDriver, we use page objects. However, there are like at least 10 types of page objects. Like you can spread them across multiple files. You can expose the elements as properties, getters and setters, or encapsulate them. You can use Fluent API and so on. So you discuss with your team what type of page objects you're going to use, and you decide that instead of putting the page objects in the same project as your tests, you put them in a separate project. Then you discuss even further that you want some kind of a abstraction on top of this framework, and you want to use Gherkin language, BDD. So you install a tool that supports Gherkin, like Cucumber, Specflow, Gouge. And as you saw in the previous lectures, there were examples about Gherkin, and I will show you later. For each sentence in the Gherkin, you need to have like mapping a function with code. So usually the best practice is to put these functions in a separate project. And later you finally decide with your team that you need static analysis. So you install such a tool like StyleCop for .NET. And because of it, you need to create separate files to put the rules. So you see, the framework is not about classes and methods. It's about how you group the code and what rules do you follow. It's not about the code only. So now when we have the definitions, I will go through the different generations of framework before we define the fifth generation of frameworks. The first one is called record and playback. Some people call name it also linear scripting framework. However, I cannot call it even a framework because, you know, there isn't code. The most famous example is Selenium IDE. How does it work? It was extension for Firefox. You play this record button, start navigating to a website, typing something, clicking, and the tool records each action. Later on, you can repeat the whole process. And all of the data is hard-coded, as you can see on the slide. So it was good because you don't have to know how to program, and you can automate fast, really simple scenarios. However, it was like a big challenge to automate more complex scenarios. It was a challenge to execute all of these tests in continuous integration or to get proper reporting. And it was hard to execute all of these tests in different environments like production, dev test, etc. Then the second generation frameworks appeared called modular frameworks. Again, the most famous example I can give you is Selenium IDE, where the two vendors decided that it will be a little bit easier to allow you to export your code, your script, to famous programming languages such as C# and Java. Here in the Selenium IDE, you can export your script to Selenium bindings like Java, C#, Ruby, etc. And later you can modify the script and change it if you want. And why do we call it modular frameworks? Because the program, our test program, is divided in different modules, like, or better say, exported scripts, which you can later combine in bigger tests. Like you have one script for logging into your application, one for creating support tickets, one for creating purchases, and so on and so on. And you can later combine them in bigger tests. As mentioned, since the data is hard-coded, it was hard to create more complex scenarios and create combinations of the tests with multiple data. Because of that, another type of second-generation framework are the so-called data-driven frameworks. In them, the test logic and the test data is separated. Usually, we place the test data in files like CSV, Excel sheets, XML, JSON. Here on the slide, you can see example from MS Test. Here in the data source attribute, we put where our CSV file is, and the test will be executed like for each row in the CSV file. So since these frameworks are coded, the maintainability is much greater than the previous generations. And you can use the power of the IDE to replace and fix the tests. However, since the abstraction level is too low, and as mentioned, we have these exported scripts, but they lead to a lot of copy-pasting development, which is not good, of course. And about the data-driven frameworks, they are great to some extent, but they make the test really hard to read because the data is in different files, and they are really hard to debug. Imagine that you have like 10 rows in your CSV file. How do you debug like the 100th row? Hard. So the third generation is called library architecture frameworks. They are built on top of the modular frameworks, but add some advantages like higher abstraction level. And the difference here is that instead of using modules, our application is divided into common methods based on use cases, business use cases. Now I'll give you an example. Here on the slide, you can see a shopping cart, like billing and shipping. And back in the days when I was architect in Telerik, we had 3 big websites. And we had one shopping cart in one of the websites. But our owners decided that we need to have like branding, and 2 more shopping carts had to be built. And of course, it was easier for our developers to just use copy-paste development, copy-paste the shopping carts, and change only the styles in the CSS. However, this leads to 2 more shopping carts, but with different locators. Back in the days, we used some kind of a modular framework. However, we discussed with my QA colleagues that it will be hard for us to maintain like 2 more copies of these tests. And because of that, we decided to upgrade our modular framework to library-based framework, meaning that here on the slide, you can see we decided to use the so-called facade design pattern, meaning that in this method, we describe in abstract our workflow, how we create a purchase. And here, the page objects that we use are actually, we use them as interfaces, meaning that for each shopping cart, these interfaces, we have different implementations. And at the beginning, the only difference between the implementations were the locators, of course. Another type of third generation framework are the so-called key-driven frameworks. They are similar to the data-driven frameworks. However, they go even further. Here in the table, you can see their keywords. They represent some kind of action that you can perform against the object. Like usually this is the locator of the object that you are going to execute the action. And in order this to work, you need to have some kind of a shared repository of objects that you need to know against the object what kind of actions you can perform. So usually the library-based frameworks are great because if there is a change in the workflow, you can change it only in a single place. However, sometimes it may happen in future that, as in our case, we had 3 shopping carts, and with time we had to add slightly different features to one of the shopping carts, meaning that it's really hard to maintain the abstraction level when the different applications start to change. And moreover, when you create such kind of abstraction, it's hard for all people to understand the code, meaning that all of the people that participate in the test automation had to be really good programmers. And about the keyword-driven development, the keyword-driven frameworks, they're actually, you know, they had all of the drawbacks for the data-driven frameworks. However, in my opinion, they tend to slow down the test writing process, because usually the people responsible for creating the repository are different from the people who are responsible for writing the tests in these weird tables. As you can see from the name, hybrid means that you build your framework on top of all others, meaning that it will be much easier for you to make this framework work in different scenarios. The only thing that is bad about this type of framework is that it inherits all of the disadvantages of the frameworks that it's built on. And another type of 4th generation framework are the so-called BDD frameworks. This is like Gherkin syntax. This is SpecFlow in .NET. I think it's really powerful technique because it's like human readable tests and is the communication between QAs, developers, and business people. And as I told you, for each sentence, we need to have this like mapping function in order the code to be able to work. So, as mentioned, hybrid frameworks, they inherit the disadvantages of all other frameworks, meaning that if the base frameworks don't support, for example, troubleshooting, or they are built only primarily for web, then your hybrid framework will have the same disadvantages. About the BDD, I think it's much better than the previous generations like keyword-driven development, and moreover, it's much better integrated in programming language IDEs like Visual Studio and so on. Whereas, you know, I saw so many weird things about the key-driven frameworks like Excel sheets and yeah. Another type of generation are the so-called Selenium-based frameworks. So some smart people decided that instead of reinventing the wheel, they will share their frameworks with the world. So a lot of open source web-based frameworks appeared. Selenite, a PAM-GDI for C# and Java, a Tata framework, Objectivity. Here on the screen you can see an example from Selenite. So I think it's much better to base your framework on top of these frameworks, because they usually give you lots of features. For example, most of them have this built-in feature for synchronizing and waiting internally for the web elements, especially for dynamic pages. And usually the tests are much more readable. And if you want, you can bring your own abstraction level on top of it, like bringing Gherkin, BDD, whatever. However, as mentioned, the primary focus usually is web for all of this. So I believe using an open source frameworks is great, especially if you are new in test automation. Instead of reinventing the wheel, you can base your framework on them. And top recognized automation engineers usually build them and support them. And some of the frameworks, they actually have big communities. However, they have some drawbacks too, like completely lack of documentation, most of them. And as mentioned, if you need like a solution for testing mobile, desktop, or web services, you need to build one your own. And since these guys are developing these frameworks in their free time, if you have a problem, of course, it's open source, you can debug it, but believe me, some of the code is really hard to understand or debug. And you can submit issue, but since they do it in their free time, you don't know when they will answer or whether they will fix the bug. So what are the must-have features of the so-called 5th generation frameworks? First, I believe they should be well documented, and not only. They should be fully covered with tests, and I don't mean here only UI tests. They should have unit tests. They should be entirely coded. I don't believe in these recording tools, etc. They are like old generations, old school. Since we live now in a really complex world, and most of the companies nowadays don't have only websites. They have mobile applications, they have desktop clients, they build their web applications like microservices and web services, so you need to test them too. So your framework should support all of these technologies, like you should be able to test web, mobile, desktop, web services. Then it should be cross-platform. You should not be limited to the platform that you use. For example, Windows or Mac. You should not be limited to the programming IDE. It's more and more important to be able to run your tests faster. Many companies nowadays, they want to deploy daily or multiple times a day. In order to do that, you should be able to execute your test, for example, between under 3 hours. To do that, your framework should support parallel and distributing testing across multiple machines. And lastly, but I think this is the most important part about these 5th generation frameworks, is they to be extendable and customizable, meaning that usually, since every team and company work in a different context, most of the time your framework won't work out of the box for them. I can say that from my experience when in Telerik I had to build a framework that 10 teams had to use it. And I can say that different teams, they had different needs. So you should allow in your framework to be extended and customized by the team so that it can fit their needs. So let's begin with the second part. I don't want to sound like only theoretical and abstract, so I'll give you examples about these features. My company, my startup, we develop this tool called Bellatrix. It is like, back in the days, what is the story? When I worked as a consultant, many companies wanted from me to create custom frameworks for them. However, I decided that this is like, come on, I built one framework for 2 years. I cannot do it for 5 companies. So I decided to create one framework and support it centralized. So we ended up with this cross-platform solution. built on top of .NET Core that can test web, desktop, web services, and mobile. So I will give you examples from it. However, I will give my best to show you how each feature works internally, and you can download the whole source code. And about each feature, you can find detailed articles about them on my blog, Automate the Planet. So don't try to remember the code. You can download it later and read all of the details. And since I'm a .NET guy, examples will be in C#. However, I tried to extract the more, you just can get the idea and write it in any language. That's my point. So first, cross-platform readiness. What does it mean? As I told you, I believe that you should allow your colleagues to work on any environment. So we decided to build our tool based on .NET Core and .NET Standard, meaning that it's cross-platform. But moreover, how do you distribute your framework? We decided that instead of downloading executables, etc., we are going to distribute it through command line. And now I will show you how it works and how you can do it your own. Sorry, I will duplicate. Okay, great. So first we create a new folder and open it. Then we open command line from here. And the thing that we need to do to install the tool is to call the .NET CLI, use the new keyword, the new verb, and then /install. And then we need to specify the template that we want to install. In our case, Bellatrix Web Getting Started. This will install the template on our machine. Here you can see the different templates that I have already installed. And now, in order this to be created in my folder, I call the same command without /install. And here, as you can see, everything was downloaded for me directly from the command line. If you open, everything is working out of the box without anything to be installed. How does it work? You can create a similar thing yourself. Actually, it's quite easy. You can do it for 5 minutes. First, whenever your project is, you just open it. And in this content folder, you need to place all of your files. Then you need this new spec file. The new spec file is actually contains the metadata for the NuGet.exe. This is like the name of the package, the version of the package, authors, and the most important part is to mention that this NuGet package is used as a template. Another important thing is that in this content folder there should be a folder called .template.config, and inside it you need to place this template.json file, which is responsible for containing the metadata for the .NET CLI, the name of the template, etc. And that's it. Later on, you just download the NuGet.exe from NuGet.org, call the pack command against your new spec file, and this NuGet package will be created for you, and you can push it with the push command with your API key to NuGet.org. After that, you can install it like I showed you. That's it. The next thing that I told you is the cross-technology readiness. And here, as I told you, your framework should allow people to automate web, desktop, mobile, etc., etc. However, there is even more important thing. I believe that when you learn, for example, to write tests in our framework for web, you should be able out of the box to learn how to write for desktop and mobile. Meaning that the API, the methods, classes should be named it should be working in a similar way. See here the example. This is code from Bellatrix. Here we use the browser attribute over here, mentioning the browser name and the browser behavior. Meaning that when you point here Firefox, for each test the Firefox browser will be created, and the browser behavior controls the life cycle of the browser, meaning that you can reuse the browser or restart it every time, which can save a lot of time. Then you inherit from the web test, which gives you lots of common services like navigation service, which you use to navigate to web addresses, and then element create service, which you use to create UI controls. This is the desktop test. As you can see, instead of the browser attribute, we use the app attribute, pointing the path to the desktop application, and again using app behavior, meaning that we can restart or reuse our desktop application. And again, instead of web test, we inherit from desktop, and we have the same common services, element creation, navigation, and so on. The same for Android. Instead of app, we use Android, just pointing a little bit more meta information like Android version, Android emulator, and so on. And you have the same services. As you can see, if you learn how to write web, you can out of the box learn how to write tests for Android and for desktop, which can be quite tricky if you, for example, can write tests in WebDriver and try to automate APM. Like the API is almost similar, but there are many things that are different. If you have like a couple of years of experience and you develop a custom framework, you know that documentation is not enough. And I bet that you spend countless hours teaching your new colleagues to how to write proper tests and how to use your framework to write tests. And I really believe that there should be a better way for allowing people to learn by themselves, not like spending hours to teach them. So so we decided to create the so-called getting started guides. Actually, we created one using the template. Actually, the another name is starter kit. I will show you what is it. Actually, we have starter kits for each technology, like web, mobile, desktop. Sorry, the resolution is not so good. But I will explain. Here, actually, in this project, it's completely it contains demos for each feature of the framework. The features are grouped in different folders depending on like increasing complexity, and each part of the feature is explained in comments. And here each feature has like working examples against a real website. After each section you have to-do file which contains exercises. And I believe that no matter what framework do you have, you can create similar starter kit for your colleagues, and this is a really great learning tool. And you can distribute it using the installers that I showed you. Another thing that I think it's like a big part, a really important feature about the fifth generation frameworks is the troubleshooting. So imagine that you have 100 failing tests, and sometimes it's really hard to say which one of them have bugs and which one catched like a real problem in the application. So I will show you like two ways how in Bellatrix we catch bugs, and I will explain how these features works. The first one is so-called full-page screenshots on test failure, meaning that the framework will detect whether there is a problem, whether your test failed or not, and at the end will create a screenshot. What is the difference between normal screenshot and full-page screenshot? Well, in vanilla WebDriver, usually in most browsers, WebDriver takes screenshot only on the visible part of the browser. However, in many cases, the action actually is happening in the invisible part. So this type of screenshots are useless. So the thing that we built actually is that we create full page screenshots. I'll show you the code in a bit. But here again, we use attributes, screenshot on fail. When you point to true, the framework will automatically detect whether your test failed or not, and will create the screenshot. Now I will show you how actually this works. By the way, again, the example is in C#, but you can use it. You can write something very similar in Java and any language. We use JavaScript. We use a library called HTML to Canvas. So when you call the function take screenshot, it executes the whole JavaScript placed from the library. Then we call this our custom function that converts HTML5 canvas to PNG, actually to base 64 string that we later using streams to convert it to PNG. Again, you can I wrote like 2 articles about them, and you can download the whole source code. No need to remember it. But here the most important part is the principle. Another way to catch like problems and troubleshooting is creating videos. However, videos are really tricky, especially if you want to create like a cross-browser video recording. Again, in Bellatrix this works in a similar way. You use attributes, and the framework will detect when your test failed and will save the video on your hard drive. How does it work? Now I'll show you again the code. We use open source cross-platform video recorder called FFmpeg, which means that it works on Mac, Linux, and Windows. The most important part, how we use it, when you call record, we create background C# process, and we start it. The most important part here is that for the different platforms, using these conditions here, we pass different arguments based on the operating system, because for the different operating systems we use different codecs, and because we use different codecs, we have different video file formats, and that's it. When you call dispose or stop, we just kill the process in C# and the file is saved on the hard drive. That's it. Again, you can write the same thing in Java. And you can download the source code. Actually, 3 days ago I wrote an article about it. As mentioned, I believe that the most important feature of these types of frameworks is the extendability. So especially if you plan your framework to be used in many teams, you should allow your framework to be customizable and extendable. Now I will show you 2 of the ways how you can extend Bellatrix, and you can do the same for your own custom framework. Here in the Getting Started guide, I will show you just one example. In Bellatrix, we have different UI controls. Instead of using a single interface like in WebDriver iWeb element, for example, we have buttons, text fields, etc. And we allow people to override the behavior for some of the actions of the UI controls. For example, if the normal WebDriver click doesn't work for you, you can just call this static delegate from Bellatrix, and you can place your own function changing the behavior. And this will change the behavior for all buttons in the whole framework. What we do here, we first wait the element to exist, to be clickable, because sometimes the element is there but you cannot click it, and then we use JavaScript to click on it. the basic idea here is that you can write, like create some kind of a behavior for overriding the default behavior of your actions. That's it. And another way for extending a framework to get some ideas is to use event in delegates or the observer design pattern. In Bellatrix, we created like this type of hooks, similarly to how you extend like any unit framework to plug in different points of the pipeline, of the execution pipeline. For example, you can extend the framework hooking to this point where the element is found. And imagine that we want to create a plugin for highlighting elements. Maybe you saw such a feature like when you run the tests, for a couple of milliseconds the element is highlighted, like in Selenium IDE. How we can write a similar plugin? Well, first we extend the framework here by using this type of hook. This is event handler that it's subscribed to the event for returning element. And the more interesting part actually is how we highlight the elements. We use this highlight element engine. In C#, this is actually, I built it using extension methods. This is this static stuff, extension method to the native iWebDriver element. First, we don't run the highlight if the execution is happening in headless mode, in Chrome headless or Firefox headless, without UI, because there is no point. And how we do the actual highlighting? Through JavaScript. First, we get the original background of the element through JavaScript, through CSS. Then we change the background using the color mentioned here as argument. Here it will highlight it in yellow. And then, depending on the milliseconds that you specified, we run background worker or background process in C# that will wait for a couple of milliseconds that you mentioned, for example 1 second, and then it will call automatically the unhighlight method, which actually just returns the background to the original value. And this is how you can build similar like highlighting engine for your framework if you need one. Actually, during the Russian talks, I created an article so you can download the source code. As mentioned, another thing about an important part of the framework is not only about the code, but actually how you group it and to have a unified way how to use design patterns, if you recall the previous lectures. And I will show you one way how we unify the page object creation in our framework. First, we use actually the so-called item templates in Visual Studio. First, let's create a folder. Imagine that we want to create a page object for a login form. So let's call it login page. And then we have different templates for the different page objects. Here, for example, we have asserted navigatable web page, meaning that if I name it here login page, the tool will automatically create for us 3 files, because in our framework the page objects are separated in 3 different files using partial classes. In one of them we place the actions that can be performed on the page. In the another we place all of the elements in the locators, and in the third one we place all of the assertions that you can perform against the page. Actually, when you build the project, because it's partial class, it will be built in a single login page object. Yeah, this is only a pattern. I mean, we inherit like here. Here actually we want we just will inherit the mobile version of the page. I will show you if you want after the demos. If you want to create similar item templates, you can do it. I will show you. It's really simple in Visual Studio at least. You click Project, you go to Export Template. Let's save it. Then this wizard show up. You can click on Item Template, and whatever design pattern you use, you can export the file. Just click on the file and click Next, and you can even add references when you create the item. And what will happen is that Visual Studio will create for you this zip file. And this zip file will be placed in the My Documents Visual Studio folder. And of course, through the wizard, you can select only a single file. But as you saw in our template, we create 3 files. If you want to create 3 files, you need to like unzip the file, then go to this VS template something, and here you can put and change it yourself and then zip it back, and you'll create 3 different files or whatever count you have. And then you need just to put it in the My Documents folder of Visual Studio, and will work out of the box. And lastly, I think it's really important for you to give a way for people to write fast tests. And one of the things that slows down at least me is creating these types of locators properties. And because of that, in Beatrix we created snippets. What are the snippets? Snippets are like shortcuts for generating code. For example, here we type the keyword, for example, text field, press double tap, and the code is generated. And on each tap you can change the name, the type of the element, the locator, and so on. Now I will show you actually what is the snippet, how does it look like, how you create one. For example, here is the snippet for our web elements. The important part here is the shortcut, V button. It will generate actually a property of a button. And then you have these literals. Literal is the part of the snippet that you can, when you press tab, you can change it yourself. You can define like default value, the name. Later you can use, actually the most important part is here in the code part, where here is actually the C#. This is it. And in this signs here, you put your literals that will be like when you press tab will be changed. And when you create such a file, you just place it in the My Documents folder of Visual Studio, and you have the snippet. That's it. So you can create snippets for like some kind of like test bodies and some kind of a code that you use very often. That's it. Not only for this type of properties. So in summary, I told you that like the differences between a library and a framework. Then we talked about the different generations and how to, you know, when you know what are they, you can pick more carefully one of them. And we defined the core features, at least for me, about these 5th generation frameworks. Give you some demos. As I told you, you can find all the source code and detailed explanations of each of the things that I showed you on my blog, Automate the Planet, and about the snippets, the installers, etc., that are more related to the .NET framework. There are excellent articles on MSDN. I actually, I didn't read books about them because there isn't. I just read the documentation of .NET. That's it. Questions?
Thanks for your presentation. What about reporters? Which reporters are supported, and does it has a default reporter or something like that?
What do you mean by a reporter? Like
we use sometimes Allure, Mocha Awesome in different platforms. What about here?
You can use Allure. or you can use like I think a PAM test portal. So it works out of the box because you use like MS Test and NUnit. Whatever framework supports, whatever portal supports these two formats, then you can use them and integrate them.
Okay, and does it support screenshots and video for all platforms or just for web?
For mobile, you have videos because usually we use emulators. When you start the emulator, of course, you have the video. And moreover, the videos are really great because you can implement, even if you implement the video recorder yourself, you can build such a function extending the framework for scrolling down each time when some action is performed. And this is excellent for the video recording because it has the same problem as native screenshots. Because imagine that the action is happening in the invisible part, then why do you need the video?
Okay, and the last small question, what about support of examples? You showed a lot of examples and they like blueprints and contains a lot of documentation. How do you support it in future releases, in changes process?
Actually, it is as mentioned, we have like 5 different projects, 5 getting started guides, and when I change the framework, I just go to the getting started immediately and change it. Go to the documentation and change it immediately. So we don't wait for for the release to happen and then to change it. You know, we just when we release everything or release nothing. That's it.
Okay, thanks for your answers.
Thanks for your speech. The first question about the screen recording, and you said it's cross-platform, but as far as I understand, it's using native OS applications to record the desktop itself. That's right?
Yeah.
Okay, and if we speak about the parallel execution when you have multiple browsers on the same desktop, how it's possible to record multiple sessions? As far as I understand, multiple sessions will be executed in multiple browser windows and they will be overlapped.
You're right. Actually, this was my speech like a couple of months ago on Selenium Conf in India. There I showed a demo of another application, free tool. It's called Mesa, it's open source runner, and actually in our company we don't start multiple sessions with the browsers because I believe that this leads to lots of flaky tests. And we do it, but only for headless modes, for headless browsers. And because of that, we use the tool to distribute the tests across like in the cloud on 10 machines and start they're like 2 CPU core machines instead of having one with 4 CPU cores. And then on each machine we have video recorders, and then the videos are later saved in a shared repository. This is how we do it.
So here's my question. Is there a way to customize the browser behavior, for example, by adding additional arguments or customizing the capabilities? If we have a specific task which needs a specific behavior of the browser, can we customize that? Or you have only a preset of browser behaviors that can be reused?
No, actually, as mentioned, the main goal of the framework is to give you a way to extend everything. So this is one of the parts. You can just inherit our behavior and then just override some of the methods. If you recall the definition about the framework, this is it. You can change the behavior. You can just throw away everything we wrote about this behavior and just change it yourself. Like, yeah, that's it. So you can do it, definitely. And as mentioned, you can do it in your own framework. I mean, it's a little bit hard to implement this type of observers. It's lots of code. But actually, you can do it in Java. You can do it in C#, in custom frameworks. It's no problem.
Okay, thank you.
Wait, and the best question? Which question did you like the best?
Oh, I didn't remember them. Sorry, you can pick one.
No. Why me again? You should choose the best. So I give the backpack to this guy, okay?
Okay.